Hi everyone, we are from Section 5 Skee 1073. Our group member have Haoyang, Qinggensan and Qinshuyan. Today, this video is introduce how the AC circuit convert to DC circuit. As long we know that the AC circuit convert to DC circuit has three things important to undergo, which is rectifier, filter and regulator. So this is our connector circuit. Firstly, we use the function generator become our AC power supply and 3 multimeter, 3 oscilloscope to obtain the voltage value and see the pattern of voltage flow through the circuit, and 2 resistor to measure the potential voltage. This breadboard is connected to all the components. So you can see the first part. For the rectifier part, we use 4 diodes become the full wave bridge rectifier. This bridge rectifier is due to convert the AC voltage input to pulsating DC voltage. And for the operation of the bridge rectifier is only 2 diodes conduct the current at one time. For example, during the positive half cycle, these 2 diodes become the forward bias and these 2 diodes become the reverse bias. Well, for the negative half cycle, these 2 diodes become reverse bias, these 2 diodes become forward bias. So we go through the next is filter part. The filter is a circuit that removes unwanted components from a signal, typically used to reduce the ripple in rectifier or to pass certain frequency range in signal processing. So we can simplify the filter as the capacitor. And you see the current flow through from the rectifier output to the ground and across the capacitor. So it will produce the ripple factor. The ripple factor is a measure of the AC component present in the output of a rectifier circuit compared to the DC component. So, lastly, we go to the regulator part. We use the Zener diode to become the voltage regulator. The function of a voltage regulator is to maintain a constant output voltage, regardless of change in input voltage or load condition. So after I introduce all the components, we need to put the input value to go the simulation. Firstly, for the function generation, we put 100 Hz for the frequency, 10 watt for the amplitude, DC offset 0 watt, and the function we use sine function. And make sure this 3 multimeter is in the voltage mode, and oscilloscope is time per division 3 ms. Set the resistor. 2 resistor is 15 mega ohm, and 1 Zener diode is set in 1 watt. So set all this value, we can start the simulation. As long you can see, this is our simulation result. Firstly, you can see the first graph is show the sinusoidal wave, and this is the correct result for the AC power supply. And the second will become the ripple factor wave. It is because the current flow through from the rectifier output to the ground will flow across the capacitor, so will produce the ripple factor out. And lastly, you can see that the current pass through the Zener diode and the voltage almost become constant DC. So this graph is show that the voltage is become the constant DC here. So this is our correct result. This show that the simulation is successfully. All of this is our simulation lah. So thank you for watching our video.